It is a 10-kilometer wide asteroid, the exact same size as the celestial object that struck Earth 66 million years ago and erased 75% of all species on our planet, including every non-avian dinosaur. Today, we are not exploring ancient history. We are walking through a terrifying, fully evidence-based scenario. What if this mountain-sized asteroid hit Earth right now in our lifetime? What would happen to our cities, our climate, our ecosystems, and to humanity? This is the complete, unflinching story of a planetary cataclysm, told with the precision of NASA's planetary defense scientists and the awe of deep cosmic reality. To truly understand the danger, we must first grasp the scale of this asteroid. A 10-kilometer rock is not a small meteor that burns up harmlessly in our atmosphere. It is roughly as tall as Mount Everest, stretching more than 6 miles from one end to the other. If you placed it on a modern city, it would cover entire neighborhoods and landmarks completely. This asteroid is incredibly dense, made of rock and metal, and travels through space at an average speed of 15 to 20 kilometers per second, faster than any bullet, faster than any rocket humans have ever built. For an object this massive and fast, Earth's atmosphere is little more than a thin veil. It offers almost no resistance, turning the planet below into an unavoidable target. By the time our most advanced telescopes confirm its collision course, the clock for life on Earth has already started ticking down, with no way to reverse it. Let us begin with the final hours before impact. Astronomers at NASA's Jet Propulsion Laboratory, home to the Center for Near-Earth Object Studies, CNEOs, would first detect the asteroid weeks or even months earlier. They track its orbit using precise mathematical models, and at first, the risk might seem low or uncertain. But as more data pours in, the conclusion becomes unavoidable. This asteroid is heading directly for Earth. Governments across every continent would receive emergency alerts, and public broadcasts would cut into every screen, radio, and mobile device. People would step outside and stare upward, watching a small dot grow brighter and larger by the hour. Panic would start as a quiet anxiety and quickly erupt into global chaos, because everyone would understand this is not a drill. This is an extinction-level event, the same kind that ended the age of dinosaurs. As the asteroid reaches the upper atmosphere, about 100 kilometers above our planet, a terrifying sequence begins. The air in front of it cannot move away fast enough, so it compresses violently and heats up to tens of thousands of degrees Celsius. The asteroid itself glows white-hot, becoming a fireball, so bright it outshines the sun. For anyone watching it, is a blinding, apocalyptic sight, visible across half the globe. The shockwave from its hypersonic passage shatters windows hundreds of kilometers away, even before the asteroid touches the ground. The lower atmosphere cannot slow it down. It is like a sledgehammer smashing through a sheet of ice. In less than 60 seconds, it travels from the edge of space to the surface of our planet, with enough kinetic energy to reshape the world forever. The moment of impact is beyond anything humanity has ever experienced. The asteroid slams into Earth with the energy of 100 trillion tons of TNT, equivalent to billions of nuclear bombs, detonating at once more power than all nuclear weapons ever created combined. Whether it hits land or the ocean makes little difference to the global outcome. If it strikes the ocean, it generates a mega tsunami more than 1,500 meters high near the impact zone, which races across entire oceans and drowns coastal continents within hours. If it hits land, it blasts a crater more than 180 kilometers wide and 20 kilometers deep, instantly vaporizing rock, soil, and every living thing within a 1,000-kilometer radius. The blast wave tears across continents with winds exceeding 1,000 kilometers per hour, flattening forests, cities, and mountains alike. Seconds after impact, the most powerful earthquake in Earth history ripples outward, a magnitude 10 to 11 tremor that shakes the entire planet. It triggers volcanic eruptions everywhere, from long dormant peaks to mid-ocean ridges, and shifts tectonic plates with violent force. Meanwhile, trillions of tons of superheated rock dust and debris blast into the stratosphere and rain back down to Earth, heating the atmosphere to hundreds of degrees. This creates global firestorms, wildfires, that burn every forest, grassland, and urban area on the planet. Oxygen levels plummet as the fires consume the air, and for days, the sky is filled with fire and ash. The surface of Earth becomes an inferno, and any creature not killed instantly by the blast or tsunami dies from extreme heat and suffocation. Then comes the long, slow nightmare that truly drives mass extinction, the nuclear winter. The massive cloud of dust, Soot and sulfur dioxide, thrown into the upper atmosphere, forms a thick, impenetrable blanket that blocks nearly all sunlight from reaching the surface. This darkness lasts for nearly 2 years, and the fine silicate dust remains in the air for up to 15 years, keeping temperatures 15 to 20 degrees Celsius below normal across the entire globe. Photosynthesis stops completely, plants die on land, and plankton collapse in the oceans, breaking the entire food chain from the bottom up. Crops wither, herbivores starve, and predators follow. The tropics turn icy, the poles freeze solid, and oceans begin to freeze over in large areas. Earth transforms from a lush living world into a cold, dark, barren wasteland, a state that lasts for decades before the climate slowly begins to recover. What becomes of humanity? A tiny number of people might survive in deep underground bunkers, submarines, or remote polar stations, places shielded from the initial firestorms, earthquakes, and heat. But their chances of long-term survival are extremely low. Without sunlight, agriculture becomes impossible. Food supplies run out within months, and there is no way to replenish them. Even the most prepared survival groups would struggle to live more than a few years. This asteroid does not just kill billions instantly, it erases human civilization, dismantles global ecosystems, and sets evolution on Earth back hundreds of millions of years. This story is not science fiction. It is a real event written into our planet's geological record. 66 million years ago, the Chicxulub asteroid, exactly 10 kilometers wide, hit what is now Mexico's Yucatan Peninsula and caused the Cretaceous-Paleogene extinction. It killed the dinosaurs, pterosaurs, mosasaurs, and most marine life. It took millions of years for Earth to recover, and mammals only rose to dominance because that impact cleared the way for small, warm-blooded creatures to thrive. Back then, no species had telescopes, space programs, or planetary defense systems. No one saw the asteroid coming, and no one could stop it. Today we are different, but are we prepared enough? NASA and space agencies around the world are building systems to defend against exactly this threat. The Planetary Defense Coordination Office, PDCO, scans the sky non-stop for near-Earth objects, NEOs, larger than 140 meters, because even a rock that size could destroy an entire city. For extinction-level asteroids, we have the DART mission, the Double Asteroid Redirection Test, which in 2022 successfully crashed a spacecraft into an asteroid and changed its orbit, proving we can nudge a space rock off course if we detect it early enough. The catch is simple: deflection only works if we find the asteroid years, not months, in advance. A 10-kilometer asteroid is so massive that even nuclear deflection missions would require decades of planning and execution. If we spot it too late, we have no defense. Asteroid impacts are not a distant fear. They are part of how our solar system works. The moon is covered in craters because it has no atmosphere to protect it. Mars bears the scars of ancient massive collisions. Earth is hit by small meteors every single day. A 10-kilometer asteroid strike is rare, happening only once every 100 million years or so. But rare does not mean impossible. It is not a question of if another large asteroid will hit Earth, it is a question of when. Please like, comment, share, and subscribe to the channel